Hi students, in this video I'll be going through the 2023 A Math paper 2 question 3. Alright, so this is a real life application question that involve exponential equations. Alright, so let's read the question. So T is poured into an empty cup. So the temperature Tc degrees Celsius of the tea in the cup T minutes after it is poured is modeled by the formula. Okay, Tc equals to 86 times e to the power of negative 0.06 t. Right, so this is basically a scenario whereby you pour some hot tea inside a cup. Then, of course, if the tea is left out in the open room temperature, then the temperature of the tea will start to decrease. All right. Okay, so in part A, they want you to state the initial temperature of the tea. All right, so initial, whenever you see the word initial, it means the time is equals to 0. Okay, so that's why they ask you to state, because you can actually do so. You can actually tell what is the answer without doing any working. If you have to put a 0 here, then it will become 86 times e to the power of 0. So anything power 0 will be 1, then 86 times 1 will give you 86. Okay, but if you are really not confident and you really want to do some working, then you can actually write sub in and see for yourself lah. Okay, so the initial temperature will be 86 e to the power of negative 0.06 times 0. So anything times 0 will become 0, right? So over here you get e power 0. E power 0 is 1. Okay, that's why you get the initial temperature to be 86 degrees Celsius. Okay, but you should be confident. Okay, you should be confident. You can straight away write this. Okay, because whenever they ask you to state, means that they want you to straight away write down. Right? Okay, so do be confident. Okay, you do more practice, then you'll be more confident about your answers. Okay, next part B. Okay, find the time taken for the temperature of tea to drop to 37 degrees Celsius. Okay, so as mentioned earlier on, the temperature of the tea is decreasing. Okay, so they want you to find after how many minutes, then the temperature will reach 37 degrees Celsius. Remember the initial temperature we just obtained is 86. Right, so basically what we'll do is we'll formulate an equation, and then we'll find T, right? So when temperature in the cup, right, of T in the cup is 37 degrees C, okay, then we'll formulate our equation. So 86 times e to the minus 0.06 t equals to 37. All right, so the way to solve this kind of question is don't be tempted to straight away ln both sides. Okay, always bring this number, this 86, right, on the left side over first before you ln both sides. Because you have to ln both sides now, right? Okay, you got the ln here now. Okay, later on the left side, you need to apply the product law. Okay, so we want to avoid doing that step. Okay, so you bring the 86 over first. Okay, so we'll get 37 over 86. Okay, so bring over first, then now it's the time to ln both sides. Okay, so remember this important step. Okay, this important method to solve. Okay, we'll continue over here. Okay, so on the left side, we will apply the power law. So we can bring the power in front, then we have ln E. Ln E is eventually going to be 1, right? Okay, then this ln 37 over 86, just compute inside your calculator lah. Okay, so you'll get 0.84343. Okay, in other words, negative 0.06 t will be equals to, so t will be equals to 343 divided by negative 0.06. Right, so you'll get your answer 14.057. Okay, so it's 14.1 minutes. Okay, round off to 363. Alright, so the important thing about this part is remember, okay, divide by 86 on both sides first, okay, before you ln both sides. Alright, let's look at part C. So this questions seem a bit wordy, but it's actually not difficult. Alright, so don't be afraid if you see questions that are a bit wordy. Okay, some tea is poured into an empty cup, and at the same time, the same volume of tea is poured into an empty flask. So now they pour some new tea into the cup, and then as well as some tea into a empty flask. Okay, so this kind of flask is most likely those vacuum flasks where they want to keep the tea warm for a longer time. So the temperature TF degrees Celsius of tea in the flask at time T minutes after it's poured into the flask is modeled by almost the same equation. The initial temperature also 86, okay, but now it's negative lambda T, okay, where lambda is a constant. So the formula for TC still applies. Okay, after 1 hour, the temperature of tea in the flask is 82 degrees C. Okay, so now they want you to find lambda. Okay, so over here, you got to be very careful after 1 hour. Okay, why be careful? Because the time that we are talking about here is in minutes. Okay, so over here is actually 60. T equals to 60 minutes. Okay, so be careful about this part. Okay, don't go and use T equals to 1 minute because that's going to give you the wrong answer. Okay, so basically they are saying that same thing, you want to find one unknown, right? You formulate an equation. So now we know T is 60. Okay, and then the temperature of the tea is 82 degrees Celsius after 60 minutes. So we know this and we know the time. So we are only left with one unknown. So with one unknown, you formulate one equation. Okay, so I mentioned this many times in my previous videos already. So when T equals to 60 minutes, okay, the temperature of the tea in the flask is 82 degrees C. Okay, so we're going to formulate an equation. Okay, so 86 e to the power of negative lambda times 60, right? Okay, will be equals to 82, right? Okay, so still remember how to solve this? Bring the 86 over first. Okay, I'm going to put the 60 in front of the lambda. So 82 over 86. Okay, right, so you can actually simplify this to 41 over 43 lah, divide by 2. Okay, then now is the time to ln both sides. Okay, so now is the time to ln both sides. Okay, so the left side use the power law, bring the power down. Okay, ln 41 over 43 is just a number. Okay, so just go and compute inside your calculator. Right, then you just divide both sides by lambda, negative 60, sorry. Okay, then you will get this. Okay, to 368. Right, so over here we are dividing by negative 60. Right. Okay, so there's one last part to the question. So paper 2 questions are usually longer. Okay, so using your answer from part 1, okay, find the time when the temperature of tea in the cup is half the temperature of tea in the flask. Okay, so basically what they want you to do is just follow instruction. A lot of times just follow instructions. Okay, so now they want temperature of tea in the cup is half the temperature of tea in the flask. So remember, this flask is a vacuum flask, so the temperature drops lower. So for the same amount of time that passed, okay, it's expected that the temperature of tea in the cup is lower than the temperature of tea in the flask. So in this case, they want the situation whereby the temperature in the cup is exactly half the temperature in the flask, okay, which is expected because the temperature in the cup is dropping faster, right? So the temperature, the formula for temperature of tea in the cup is this. Okay, so this one is given in the original question. Okay, it's given in the original question. Okay, so we're just using this one. Okay, the original question. Okay, then in part C part 1, we got lambda to be 0.000794, right? Okay, so we're going to use it in this equation. So remember, formulate an equation to solve. Okay, so times 86 e to the power of negative 0.00794 t. Okay, so this is the equation that we have. Okay, there's an equal sign here. Okay, so we're going to divide the 86 over first. So if I divide both sides by 86, the 86 will cancel off. So over here, I'll just be left with this. Okay, so we must be wondering how to solve this. Do we ln both sides or what do we do? Okay, so what I would recommend is bring this one over first and combine these two, okay, using the law of indices. So basically, if I divide both sides, okay, so do you still remember how to apply a law of indices? So AM over AN will be AM minus N. Okay, same base, you subtract the power. So I'll subtract the power now. So subtract the power. The power below is negative. So subtract the negative value. Okay, so over here you got to be well versed in the law of indices. Okay, so if you subtract, you sum together, you get this one. You get this. Okay, then we will ln both sides. All right. Okay, then bring the power in front. Okay, using the 59206T. Okay, then you will get ln E, but ln E is going to be 1, right? Okay, so you'll get this answer. Okay, over here you'll get ln E, but ln E is equals to 1. Okay, so maybe I just write the extra step, right? Okay, so we'll write here ln E equals to 1. Okay, then so what we'll end up with is this. Okay, so ln half is actually just a number. Okay, so if you use your calculator, you compute out, you get an answer. So just T will just be this. Okay. Okay, so if you compute this out, you get T equals to 11.7 minutes. Okay, 366. Okay, so that means after 11.7 minutes, the temperature of the tea in the cup will be exactly half of that in the flask. Right, so this is a good question on exponential equation, application of exponential equations. Okay, so do try the questions first, and then do try such questions on your own now. Okay, it's not that difficult.